very pleased to introduce my great colleague, Ilias Katsardis. He is a senior product manager for AI infrastructure at Google Cloud and the perfect person to tell you all about Cluster Toolkit. Please welcome Ilias with some applause meatmojis.
I think that's the like where I get in. Hi, people. Good morning or good afternoon, depending of where you're coming from. My name is Ilias Katsardis. I joined Google 7 years plus something. I think in this team, Wyatt predates me by something like 6 months. And I came directly from Cray. Wyatt came from Seagate, actually. At that point, it was the two of us that Google was actually searching for high performance computing, and they heard this from customer demand, so they hired me and Wyatt to go and deliver. And I think that's the point where I'm starting to feel older, because now I'm starting to say stories in the meets and the talks instead of actually speaking about the today. So as I'm starting with the story, let me tell you the one that I found when I actually met Wyatt 7.5 years ago. At that point, HPC was starting to appear in Google Cloud and any cloud at that point, right? And the request was simple from our point of view. It was like, can we actually have Slurm in our cloud data center for our customers and give them a high performance computing cluster? So, okay, how do you do this? It started up being a very, straightforward issue, right? You have 20 nodes, let's say, or 100 nodes. Doesn't really matter. You take one of them, you compile Slurm, you make that node the controller. If you really need to, you make another one for high availability, and then the rest of the nodes are either login or compute nodes. And that is a very static cluster that works. So naturally, customers basically said, but this is cloud. It has infinite amount of CPUs, which they later found out that in the GPU case, there's no such thing as infinite. And my bachelor was in mathematics. So when it comes to actual compute nodes, we have a lot, but not infinite, right? It depends on what your limits are, I guess, and your demands on this, if you find out the limits at the end of the day. But in the 7 years plus example here, we actually had our customers and they said like, well, I don't need this node every day. If I needed this node every day, I would be on-prem. Of course, they haven't heard about the discounts we give if you do have this node every day, but still, it made sense for their use case to be elastic. So capacity comes up and down as the jobs come up and down automatically by Slurm. This is something that Slurm for cloud was not really meant to do at that point, right? So we actually work with SchedMD, and we leverage the feature where basically it's powering on and off the on-prem nodes. But instead of actually doing the PXE on and off, we were actually doing the equivalent G-Cloud command to spin up the node and spin it down. That looked to Slurm as the node is basically back on power, but it was actually kind of was, right? Because our nodes are also powered on from our underlying resources when we were using that. So that kind of story led us to work with SchedMD. And to the best of my knowledge, we were the only cloud that actually was in their GitHub. And we had this joint Slurm-GCP project, directly open source to the rest of the community. A lot of other products have spun up from that effort, both from other clouds and also from on-prem customers that wanted to burst into cloud. And this is really honoring us, and it's something that we're really proud of, to be able to go and help the broader HPC community to leverage Slurm more effectively in cloud. And kudos to SchedMD and also me and my colleagues mostly for managing to do that. So then you had a Slurm cluster. You had some scripts for it. It was creating the VPC, the firewalls, all the necessary rules, etc. But then customers, of course, don't just want a Slurm cluster, right? You want a Slurm cluster with some parallel file system, an NFS file system maybe for your home folder, for your home files. You need 3, 4, 5, 6 other things on top of that as well, right? So then you have a complete cluster as you would on-prem. That brought the chicken and the egg kind of paradigm, where basically now you had the Slurm script that could easily give you a cluster, and then you had the Elasticity script that would easily give you a power file system. But both assumed that you had nothing going on in your project. So both they were creating a VPC and both they were actually going through all of this. So the question then became, okay, so what comes first? Is it Slurm or is it Elastic? And then you can imagine that we have a lot more products after that or before that that also need to be in that picture when you're figuring out that pipeline, right? So that problem, we brought Cluster Toolkit to actually solve. Cluster Toolkit has one objective, which is to make it easy for our customers and partners. We should underline that because it's very important tool for our partners to get up and running using the best and greatest from Google Cloud today. But the repeatable turnkey environments, according to our own best practices, which are, of course, HPC best practices in Google Cloud, right? So in short, basically, it's like if you know nothing about HPC, would you still end up having an efficient cluster in Google Cloud just by using our defaults, right? And the answer is yes, but you need to have Cluster Toolkit in this case. And the idea is because here's how many actual services Cluster Toolkit is enabling and using, and maybe in some cases even abusing for our customers to end up having a complete solution, right? You can see all the different schedulers, the operations, all of the different networking components, user, compute environments, etc. Now, the idea is that Cluster Toolkit in 15 minutes can spin up a cluster that the equivalent for that for on-prem in an on-prem world will be like the equivalent of rack and stack, stripping the hardware, making sure that everything is connected. You run some kind of acceptance testing, performance testing, etc., until you get to the point that you actually end up having your cluster on-prem. So basically, whatever it will take you 3 months in the physical world, in the cloud world, it takes you 15 minutes, right? That's how good it is. But also, that's where the danger is, because the easier it is to actually get a cluster up and running, the more important is to get it correct. Because if you spend 3 months on-prem to do all of this, you as a human, we're all humans after all, you take time to think about it, improve, optimize, etc. Now, if I can give a kid a bazooka in 15 minutes, you end up having a cluster in this case. How much did you actually understand? So the gravity here is greater on us, that we need to ensure that all of these cluster toolkit and clusters that we have actually enabled are actually the best, more efficient that they could be, just because of the ease of use, right? The ease of use is bringing up an extra burden for us to make sure that this works. So Cluster Toolkit is even more important to allow you to do that. I would say that we can do a very bad job very easily. It's very hard to actually do a very good job, right? And that's where we are aiming for. Now, we define cluster in 3 categories, if you would like. The first one is the infrastructure. If you think about it like Lego blocks, these are the Lego bricks that make up everything else on top of that, right? They're the prime components that we have in our Google Cloud infrastructure that then customers would actually end up combining in one way or the other to end up having a cluster, right? So things like network storage, all our file systems, and of course, managed cluster, that it's our latest addition to the repertoire. And then, of course, all of the compute instances harmonically go and marry together to basically end up giving you the basic components of your cluster. Then we have modules. Slurm is such a module. Chrome Remote Desktop is another, Spark, etc., which are meant to augment and improve and add functionality to the cluster, and of course, ease of use, right? And then the kind of glue that brings everything together is the actual blueprint, right? We have three kinds of blueprints, which are general purpose, like give me compute nodes up and running. We have specific workload, specific blueprints, like I want, an HPC cluster for manufacturing, for example, right? What are the best things that I can have there for that specific use case? And then, of course, they're partner focused, where our partners want to end up having the best cluster that corresponds to their product and the thing that they're partnering with us for, the use case. So here's how Cluster Toolkit, behind the scenes, simplify your life. Because it's true, infrastructure as a code is a thing that exists. And the customer could go today, they could write Terraform, and they could spin up a cluster, infrastructure as a code, the way they want it, right? But that will be today 40,000 lines of code for Terraform. Nobody wants to not spend 15 minutes to get a cluster up and running and write 40,000. There are a lot of customers that see the value of having a YAML, and that is our default blueprint, where basically it ends up on 62 lines. And then in these 62 lines, you define everything about the cluster that you want in a simple, straightforward manner. I'll show you some examples. And then you can actually go and deploy that directly if you even don't want the deployment artifacts, right? Now, we do have some customers that before they actually deploy the artifacts, they want to take the modules from Cluster Toolkit, the Terraform modules that we produce, and then use them in their own CI/CD pipeline, etc. That is also a valid use case, but it's a little bit for more advanced customers that actually want to finely tune the finely tuned product on top of that. And usually they have some kind of an issue on their end. Like, for example, they need to have their security teams actually be the ones that deploy this and not their users or admins, right? So that way, the security teams feel a lot more comfortable when they actually see the actual Terraform code. Now, here's an example of basically how does a blueprint look and how easy it is, right? If you are familiar with high-performance computing, especially with Slurm, this is a lot more straightforward because that's how we designed it as well, right? So you put some generic global variables, like the zone that you want, the project ID name that you want, and your deployment name. Then you define your network, you define the home file system, and then you tell it to attach to that network. You have a debug node set for your Slurm jobs, just to make sure that you have some nodes that you can spin up and down and do some basic things. Then you have your first real compute node set, which you can actually see that you define how many dynamic nodes you wanted to have. You can say how many static, how many dynamic, etc. You define your partitions, your Slurm login node, and of course, lastly, your controller, which basically you're telling it to use all of these other components. And that's how you brought all of the Lego blocks into the controller to finally have everything in one place. Now, whoever is presenting, can I present Jay actually, so I can show the video?
Yeah.
Or yeah?
Yeah, go ahead. I'll unshare now.
Thanks, Marie. Second thing. Thing is believing, so well, to at least, actually, I wanted all of you to actually spin up your own cluster while we're doing this, but I will settle for the next best thing, which is what one of our colleagues, anyway, in this case, spin up his cluster, right? So you can very quickly see that basically Anyway has one command here on the G cluster deploy. These are the blueprints that we actually have for the A4X machine that we have. And you can see basically he's on his work environment. He's running the G cluster to actually go and deploy everything in one go. And then you can see all of the different steps. I don't know if I can actually, but I made it a little bit bigger. So you can see basically, I'm going to add 25 new things. Do you want to proceed? Yes. And then the most important thing is like now it's like a fire and forget missile, right? You can see everything that the script is doing on the back end. It starts from creating the VPCs. You can see some blurbs here that it's actually trying to create the firewalls and network address translations, routers, and the whole thing. Like these are not typically things that a Slurm administrator will actually want to do in cloud or in real life, right? Normally, you would expect that all of this is there in place from your vendor. They spend 3 months rack and stacking. So, all of this comes there, but the knowledge is lost on how to do it, right? So now the other hidden benefit with Cluster Toolkit is that the knowledge gets added back to the community to understand, yeah, but here are all the things that you would do if you had your own on-prem cluster right now and you didn't buy it from anyone and you just put the materials together yourself and then you just went ahead and deployed, right? I'll make there a little bit more on the cloud computer world, like you wouldn't need to create a VPC if that was an on-prem cluster. But the rest of the steps on how to even compile Slurm, put it together, set it up as a controller, add the partitions, all the different Slurm configuration settings, everything is there. So even the image, the way we make the image is also a blueprint for that. So that is also public knowledge for us. Everything is there, full transparency for our customers to use and see exactly how we are doing everything, right? So as you can see, basically, I will speed it up a little bit just so you can end up seeing everything. So your cluster ended up basically being deployed, right, in whatever 2 minutes 46 seconds, and then you can see, you can now basically go to your login node, and we have Nickel just as a basically as a basic health script for you, just to make sure that the bandwidth that you get is conforming to our expectations of performance. One hidden eye candy here is that Bluebird actually is that you can get to see that under the hood we're also using Rumble, which is another great product from us, from Google Cloud. We can tell you, if we haven't told you about this, we can tell you in another meeting as well. But basically, Rumble makes it very easy to use Spark, and then also extend Spark to also the run plane, right? So you can also run a lot of different scenarios now through Rumble that also leverage Spark. You compile, you run different kind of binaries and sets in a different number of architectures. Now, Mary, do you want to share again, or shall I continue?
I'll go ahead and put it back.
Perfect. Let me stop sharing. Thank you. So, can you give me? Yeah, thank you. Just making sure. Yes, correct. All right. So we have, of course, a lot more blueprints. As I said, we have even workload specific ones. You can see some Fluent, WRF, OpenFOAM, GROMACS, and a few others in there. They go by storage, scheduler, machine type, and operating system. Of course, all of them are ready to use, and you can click the link once you have access to the slides, or you can just navigate directly to the link, and you can actually start experimenting using them and even going production with them. Now, I wanted to deep dive a little bit because an architecture diagram helps understand some of the different components. I'm using the example for GROMACS. You can even scan the QR code. You can see the demo or a blueprint. So what this will give you is basically from APIs enablement to VPC creation with your GCS buckets and file store for the home file system and run file system. You get Spark out of the box, which actually is the one that goes and installs Intel MPI and the necessary components to actually compile GROMACS and use it. You get your Slurm cluster, of course, with your controller, login, and your CPU, GPU nodes, storage. You get Chrome Remote Desktop out of the back of that, with, of course, VMD in there. And last but not least, the monitoring dashboard for your whole cluster, that basically you can actually go and deep dive into what is going on this cluster and the nodes, etc. So in architecture view, basically this is how it looks like. The user can either log in to the node, to the login node, or they can just go to the remote desktop. They can have access through the storage, and of course, storage with Spark Builder is basically closely integrated with each other. So it gives access to a shared file system for your compute nodes and login nodes to actually have the software available for you. And then basically you just go and you submit the job. Now, another product that we have on top of that is that if you focus on the bottom layer, you basically have your YAML, which you edit in a text editor, right? Your favorite one. And then once you define your requirements, that goes into the GHPC, the Google Cluster HPC engine, which is a binary from us. It will basically get all the modules that we have created with Cluster Toolkit, like from Terraform. We'll have Packer and other scripts that we have. And then it will give you the output for your deployment blueprint. And then it will give you the deployment HPC environment and everything else that Terraform gives you once you deploy it. Now, there are a lot of customers actually that want to simplify even that. And they want to have a GUI on top of everything to actually manage all of these underlying process. Like they don't want to go, for example, and select in the YAML that this needs to be a persistent disk, SSD, or hard disk, because if they do it in the YAML and they're first-time cloud user and Slurm and HPC and all of that, they don't actually have the time to go and learn that, okay, in terms of persistent disk, we have two settings. One is the PD-SSD, the other is the PD-HDD. We also have hyperdisk. We also have a lot. As you keep adding options and options, it gets more and more confusing for customers. So unless they want to go with the default blueprint and go with it, there's also one more option that helps them explore the variables there, which is the open front end, which basically, instead of you having to input precisely the word that you need to use the component for, you actually have a drop down. You can select one or the other. It can also come with a handy explanation message, so it enables customers a lot further, and it makes it a lot easier for them to deploy a cluster. If that's something that you are ending up doing a lot more often, rather than once in a year, for example, for a blueprint, then that might make sense for you. The other important thing with the HPC Open Frontend, once you have that, you're basically getting extra capabilities, right? So some of those capabilities are that, as I said, you are able to deploy it from a graphical front end from your browser. Basically, there is a local browser that is hosting the Open Frontend solution. That itself leads to actually having less errors when you are selecting your cluster, right? Like, for example, on the cluster name, we have seen people trying to actually add a whole book there in terms of clusters, right? The reality is that they do exist some limitations in terms of how long the name should be and what characters are allowed. But when you're adding a YAML, you don't necessarily find that out, right? But if you're actually typing something in a web browser, then you can even do the auto check, the autocorrect, and you can actually check for validity right in place, basically, right, when you are writing this. And then it doesn't come as an error after 10 minutes that you deployed your cluster and you see that the deployment failed, and then you're searching the logs to see where it was wrong. Because the reality is that if you did that mistake, maybe you have done a few more along the way as well, right? So that simplifies it. It also basically, because it gives you a front end for Spark as well. So you can now go and install new software from Spark or from NVIDIA NGC containers into your cluster by simply typing their name. It can even autocomplete, right? So it populates from all of the software that Spark has. You can start typing OpenInfo, and then it will autocomplete foam and allow you to select which version and everything, and then it goes on and builds. We also have Jupyter notebooks from the Vertex AI Workbench, which are also mounted into your compute node file systems. So then you can do pre-processing and post-processing on your files if you need to for the jobs that you are going to submit before or after you did it. And then last but very important is the extra step on that allows you now to actually submit jobs directly from the front end. And if you do that, submitting jobs from the front end instead of giving your customers or your users internally access to the cluster directly, then it means that it comes with a handy spend control list on top of everything, because now all of the jobs go through the front end. The front end is actually having a gating mechanism, which basically sees like these users have been assigned with X number of dollars, and this job is going to get more than that, or they have already consumed all of their money, all of their currency for that. So their job is going to be basically declined, right? And of course, a lot more that we actually have added to the product that I wasn't able to fit in just one slide. But in reality, what Open Frontend gives you is kind of the best of both worlds, right? It gives you Cluster Toolkit, which is the best from our side, and it gives you managed Jupyter notebooks and a lot of other things that are actually managed from Google, like, of course, file storage is also a managed file system, right? You don't need to manage everything. And then on top of that, we're actually adding things that Toolkit is already using in one way or the other, but then we are also getting this to the next level with the Open Frontend. So we're adding a lot more Ansible support. Customers end up with a Django framework on Python, basically, that they can see all of these actions correlate to. Everything is open sourced as well in the Cluster Toolkit community contributions. So even if you are a partner and you want to basically create a shell product, you can just reskin this and then just get some capacity and basically sell this to your own customers, right? Or use it internally. So if you decide to do that, you can find the HPC Open Frontend into the Cluster Toolkit community contributions. And all you really need to do to get the cluster up and running there is basically you just need to have a service account. You create the network and file system through the Open Frontend, and then you just press create a cluster. We can have a dedicated session for that if it's really important for customers. Also, we have an exciting announcement that we can make, not now, but at the end of the year. So be tuned for that one. And that basically concludes my talk. And the most important part is coming, which is hopefully the questions. I haven't had time to read all of them. So some people introducing themselves. Jay, what kind of questions do you have for me?
Ilias, that was great. Everybody should give Ilias a round of applause. That was a wonderful presentation on Cluster Toolkit and the beginning of Open Frontend. And yes, you can bet in the future we will have a session on that. I'm going to look at the Q&A here real quick and pick some of these to ask. We've got plenty of time for questions. Let's see. These questions are highly varied. So Ilias, they're going to come at you in different directions here. But
Perfect.
Here's an interesting one from Diarmuid Buckley. Is there any graph tool which walks through the dependencies of entities involved in the apply command?
Let's have that one more, because I think I recognize the person. So I completely ignored what you said after that there. I'm like, where is Servant?
So the name again was Diarmuid Buckley. And the question is there any graph tool which walks through the dependencies of entities involved in the apply command?
That's a great question. I know that Spack actually, that's the primary job that it does. I don't think that we're actually creating a DAG for deploying Cluster Toolkit. I don't think we had to. I might be actually very wrong on this and our engineers are going to kill me. But I think that basically we would create the Terraform deployment. And then if Terraform is using, any kind of graph on it, then basically that's where this all will happen, right? But our job is we create the modules for all of these different Terraform entities that we need to create. And then we also give the blueprint, right? And we kind of orchestrate what needs to go first in a sense. But I don't know if we do it as scientifically as actually a DAG for that.
All right. Diarmuid, if you send us an email, and my email address will be at the end of the presentation, we can check into more details about that as well and confirm what Ilias said. Let's see, there's another question from Caden Ellis, and it says, I heard collaboration with SchedMD stopped. Why is that? And I think Ilias, I think the answer to that is that collaboration has not stopped. We're actually still working with them on multiple things. And during the presentation, I actually checked with Annie Ma Weaver, and she said we're working with them on Slurm-GCP, Slurm images, POCs with joint customers, which are limited in quantity, and to talk to GCP account teams if you're interested. Do you have anything else to add on that one, Ilias, about the ongoing work with SchedMD?
Yes. And I think that I know where this might be coming from, because HPC users are not really big into chit chat and gossiping. So if you have heard that that we have stopped, maybe you or someone has actually seen that the SchedMD Slurm-GCP effort in their GitHub has stopped. That does not mean that the effort has stopped, though. If that's the case, it just means that we changed home for the Slurm-GCP GitHub instead of SchedMD to actually be the actual Google Cloud Platform GitHub.
Great. Thanks, Ilias.
So it has not stopped. We have access to the funding that we give for this project. If anything, it has skyrocketed in terms of how much we're working with SchedMD. I think at this point we're meeting them at least once a week. I meet more often SchedMD than I meet my own family back in Greece. Absolutely, it has not stopped.
That sounds to me like your own family is less than once a week, then, from what you just said, Ilias. So I hope
maybe we have less problems in Greek family.
Bill Turner asks, and I think we might rephrase this question from a cluster toolkit perspective, but Bill Turner says, the actual question is, I'm curious if you've determined the theoretical maximum of Kubernetes clusters that can be powered by the NVLink and NVIDIA GPUs. The Slurm announcement earlier this year was extremely exciting for parallelization. Ilias, I'm going to ask you to answer this more from a cluster toolkit question. What are the upper limits on the sizes of clusters and the number of clusters that Cluster Toolkit can provision?
Yeah, actually, it's a great question. It's a tricky question, right? Because it also depends on your definition of, what is the limit, right? Is 60% efficiency in an HPC cluster, to scale your workload efficient? Is it enough? Right. And then if you have, let's say, 10,000 nodes, but the biggest job is 1,000 node job, do you consider that now that cluster is inefficient, or is it efficient because it's scaled on 10,000, right? So I think we have to separate the business case with the technical use case. And then the business case, I think it still has way more scale to grow, to even reach the technical limits of that. In other words, if you have a cluster, let's say, for the argument's sake, that it has 100,000 nodes, for example, right? And let's say that this is one of the limits that not even Kubernetes, but maybe some other component is trying to fail, right? Would you, as a customer, have a job for 100,000 nodes all in parallel in a title cap with workload? I haven't seen one workload like this. Even with the LLMs right now, it doesn't go to that scale, right? So I think the answer to your question is, in theory, there might be limits. In practice, in the real world, right now we're limited about gigawatts that we can deploy, right? Before we even reach these limits, where is even the power, right? And I'm pretty sure that if people start investing in the power and we have all of that, then the other part is going to be a lot easier to actually solve. The reason why these limits exist is because someone created some algorithm that it's good enough for that, right? And then, of course, there's always the cheat, right? You can always say, like, okay, but if I'm a customer, do I actually want 100,000 nodes in the same data center? Will it be more resilient for me to actually have 50,000 nodes here and 50,000 nodes 500 kilometers or miles away from that? So basically, I have more of a resiliency structure going on, right? And then a few other more comments like this. But yes, until we get to a point where we need 100,000 nodes, I would say, to actually run the same title coupled workload, I'm not worried.
And Ilias, I'm going to follow that up with a question I think our listeners would probably like to know is, what is the resiliency? What is the failure mode for Cluster Toolkit? So you just kind of hinted at that when you said maybe it makes more sense to have two 50,000 node clusters than one 100,000 node cluster. But what explicitly is the method for handling failures? If a customer spins up a cluster and wants to keep running Slurm jobs on it, how does it handle node failures? And does the customer see that, or is that handled behind the scenes?
Yeah, I think you will have a few different friction points here, right? First of all, it's, let's say, maybe the hard limit from us is how many VPC, how many nodes you can actually have in the same VPC. I don't remember out of hand, but that number is skyrocketing high, something like 35,000. I don't want to misquote anything here. We can follow up offline and we can check, but it's a very big number for a single VPC. It might be even bigger, and then I'm still remembering it's 35 from years and years ago, right? But the point there is that now you give a Slurm controller this many jobs. Let's say now you have one job per node. Now that, let's say, translates to 35,000 jobs. Does even Slurm have enough memory there in that single VM in the controller node to actually have all of these and serve all of these nodes, right? So I think before we even get to, the Google side, I'm like, again, the business side, right? Do we even have a customer today that wants to submit 35,000 jobs at the same day, at the same time, at the same hour, at the same minute to a Slurm cluster? If we do, then I will promise you from our side that bring this customer and we will actually make sure that, all the VPC is not a problem. We have a lot of smart guys that can solve this problem. The hard thing is the business case in this.
Right. Let's see. Bill Turner asks about HPC OFE. Do you have a CVE scan built in, or do you need to run it separately?
So you need to run it separately. We do almost once a year to make sure that, at least we get our good enough is good enough in this case, because the OFE is not meant to.
Bill doesn't like that.
Hear me out, Bill. The OFE is not meant to be as something that is accessible for all of the customers out of a single login that is shared for all of them. The OFE node sits inside your Google Cloud project and is just for you, and it's behind your VPCs. So the advice we have to our customers is deploy it internally, make sure the Google Cloud firewalls are in place, which we also add, right? That limit access from external sources. So the OFE shouldn't actually be accessible from outside to inside, right? It should only go outside for SPAC or NGC containers and things like that. And even that we have different serving. So yes, the CVE is something we do once a year, but then also we don't want to overload this, because at the end that's cost to our customers at the end of the day, and this is an open source component, right? So at the end of the day, we want you to make sure that this is behind the Google Cloud firewalls, and that's the way that it should be deployed. So if you don't trust your internal users, that's another problem. We didn't go crazy on this, because effectively the use case here is that you do give your customers the ability to submit bash scripts from one controller node to potentially hundreds or 35,000 and more nodes in this case, right? So what's the point of super limiting the login if you already trust these users to submit the jobs, right? But of course we do have checked in the past, and we check for customers, and we also work with NAG, who also offers a managed service on top of Open Frontend. So if security is something like you're thinking that you need to expose that and actually make sure that every single day you're running maybe a CVE check, I'm pretty sure that NAG would be, Numerical Algorithms Group would be more than happy to talk with you about it and then figure out a way to do it. For our use cases, I think it's good enough. We can always do better, of course, but we prefer to actually add features and other modules and things like that. That part is something we hear less.
Great. Thanks, Ilias. A reminder to those who are on, submit questions in the Q&A feature in the bottom right corner where you see the 3x3 array of dots. Click on that and click on Q&A and then submit the questions in there. That's where I'm scanning for these questions from. The next question submitted was from Lucy Hutchins. She says, what's the recommended way to scale the cluster nodes, login node, compute nodes, etc., after the initial cluster deployment and configuration? I believe with the older HPC toolkit, you had to update and redeploy the blueprint.
Yes. This is the most bulletproof way that we have found, that basically you go, you change your blueprint and you update the number of nodes you actually want, and then you reapply the changes, and then Terraform will basically see the deltas and apply it for you. Now, if for whatever reason a customer doesn't want to do this process, they can actually see exactly what we're doing when we are doing the Terraform apply, and they can just go to Slurm and change the Slurm configuration and all of these things to the Slurm directly. The reason why we have it in Cluster Toolkit and Terraform with reapply is because then you're tracking this change, right? If I give you a cluster with Cluster Toolkit and then you start removing this part or that other part, or you're doing a little bit of picking on some kind of text file, then the cluster I deployed and the cluster you ended up having after you changed it are no longer the same thing. So then, basically it becomes a once in a lifetime experience that you created a cluster, and then the cluster became more of a pet that you now grew manually, right? That's kind of the case. That's why we're using Terraform and Cluster Toolkit to maintain the changes there.
Awesome. Thanks, Ilias. Brent G asked, what is the latest supported Ubuntu version?
I would say 24, but it also depends on what kind of machine you are using.
And let's see.
Like if you're telling me that you want to use N1 or or a GPU, maybe A3M, A3 Mega, maybe those are still on Ubuntu 22 and some on Ubuntu 20, for example, right? And then for our HPC machines, usually we have Rocky, and we're quite happy with it. So, if there is a business need for an Ubuntu for something else, we can always discuss about this. And again, our recipes are out there. We have a blueprint for an actual image creation. So it's not like if we don't have something that it's entirely impossible for our customers to actually get a blueprint together for the image that they want.
Great. Also, I should point out, since you mentioned NAG in that, it looks like Imantas Kazakavicius has posted in the chat. He said, now that Ilias has mentioned NAG, smiley face, if you're interested in HPC managed services for OFE, get in touch with me, and he provides his email address in there. And again, I really encourage the community to share your what you do, your HPC professional information in the chat, in particular your role, your organization, and your email address. You may be surprised at the number of contacts you make and connections you make about people who could be good collaborators, clients, customers, etc.
Jay, you are very brave, I have to say. I worked with Amandas for years and years. I don't believe I've ever tried to spell his name in public.
Did I get it right? Did I do good?
I have no idea. I mean, it's like Katsardis, right? It's a difficult name in a sense. So.
Oh, Katsardis is easy.
Yeah, very much.
All right. Finley Bertram asks, what features and best practices does the HPC Cluster Toolkit provide for managing multi-tenant HPC environments? Specifically, how does it help with security isolation, cost allocation, and customization for different end customers?
Yeah, I think that's something we have to discuss, right? It starts all from Google Cloud itself. I don't know, how people are familiar here and how they're not, but in Google Cloud, every project is its own thing in a sense in your organization, and every project has its own tenants, its own IAM rules. Of course, you can inherit them from your organization, but you can also see the spending by project. So it's like every project is actually an apartment within the same building block that your organization is with the whole thing, right? So multi-tenancy and things like that, by default, we get a lot of benefit in being in Google Cloud, right? Because let's say you're a university, your physics department can have their own project. Your mathematics department can have their own tenant. All of these billings, they're coming per project in the grand scheme of things. So, for example, if for whatever reason mathematics department doesn't want to keep spending or whatever, right? You can actually limit that just there without affecting the rest of the organization. Now, if you want to just have one project and then have every department in your company joining that, and then you need to have multiple projects in actual clusters in there and things like that, that's also possible. We have to discuss about plus and cons and what's there, but essentially Cluster Toolkit can spin up a VPC specifically for each cluster, or they can kind of use the same. So you have a VPC specifically for each cluster. You can assign IAM permissions per cluster. So specific users can only have access to one cluster and not the other cluster. And you can spread it and fine tune it in terms of, you want them to be admins or just users in those classes, etc. And then at the end of the day, you can also have billing separation in terms of maybe at least understanding it, because you can put labels. So then you can say, give me a list of compute costs or something with that label, and you put the mathematics label, for example, and then you get another one for the physics label, right? But at that point, the assumption is if you have everybody in this project, the high level assumption is that you would want them to communicate and work with each other in some way and fashion, because if you didn't, then you would just have two separate projects.
All right. And the final submitted question before we get to final announcements, Yashesh Shroff asks, do you have observability as part of the workload and cluster job and health metrics? Connectivity with managed Prometheus/Grafana dashboards may be great. Utilization metrics would also be well received. So the question, the opening question was, do you have observability as part of the workload and cluster job and health metrics?
It's great because it's a great question, because every time I answered yes, we do, or every time I started by showing the observability, it has like a build-up question, right? Because then the next question is like, okay, now that you show me all of these, what can you actually do so I don't have to do anything about that? So, if I have an observability that shows you that something is wrong, then the next very straightforward question out of that is like, why do you even show me and you don't handle it, in a sense, right? So then we're getting slowly build up to that kind of a managed product. That we have already announced publicly a few times already, and we have a public blog about Cluster Director that we moved to private preview, and now we are making progress there. But there is a blog that I can refer that is public, which is mostly basically taking this next step to our journey in Google Cloud and creating a fully managed product for our customers. And I will be able to say a lot more about that publicly at the end of the year. If anyone is interested about that, they can actually reach out to me after this, and we can discuss, or they can apply for private preview access on our website. I can follow up with a link afterwards, Jay.
And also they can sign up for customer meetings if they're attending SC, where we can discuss non-disclosure things. And Ilias, you'll be at SC too, right?
I would love to actually meet all these guys in person if they're there. It's a great opportunity to connect.
Great. All right. I just wanted to share a few upcoming events. On October 28th,